So what we will do is we will, at the end of every session, I will share a Google Colab notebook. You can open it in Google Colab. You can also open it in Jupyter Notebook. So it's totally up to you. Okay. And I will explain everything present in the notebook, and I will make sure that you're able to understand and implement them on your own needs, on your own data sets as well.
Okay.
And also for every session, I will also share the video as well for the recording. Okay, so let's start with the basics. So this is the session one, and it's going to be more oriented about basics of Python and what environment you should use and all that stuff. Okay, so we are in Google Colab, but you can also use Anaconda Navigator or Jupyter Notebook, or you can also use VS Code. Now, let's talk about the comparison if we want to do a comparison. I am also opening Jupyter Notebook here. No, the benefit of using Google Colab over Jupyter Notebook is in Jupyter Notebook, you are using resources of your own laptop. Okay. If you are working on some project and you have already opened 10 or 20 different tabs and you're researching something and you are also using programming. So basically you are coding on your own laptop and it will be resource intensive and it might hang your laptop, right? But when you are working in Google Colab, you are basically working on cloud and nothing from your laptop is going to be used. Do you understand?
Okay. Yes.
Okay. So there are benefits of using everything, and there are also cons of using everything as well. Like if we are in Jupyter Notebook, basically Jupyter Notebook and Google Colab are kind of same thing. Like if I just open a notebook and I will show you. So this is something that you already used, right? And this
Yes.
is Google Colab. Okay. Now, one thing is pretty common. We can use Markdown. We can write notes. We can write code as well. And this is pretty common, and most of the things are quite similar in both of these. Okay.
Mm.
And the third thing that we can also use if we want to is VS Code. Let me show you how it works.
Okay.
Now, this is another application. This is VS Code. Whenever you start working in some office, whenever you're working in a group project, most of the time people will be using VS Code. Okay. Now,
Mm.
why they are going to use VS Code instead of Jupyter Notebook or something like that? Basically, the main thing is whenever we are working in programming environment where we are working with Python, where we might be in a big project, so we're also working with different programming languages at the same time. We are using HTML, we are using CSS, we are using JavaScript at the same time, along with the Python, right? And
Okay.
the VS Code is the kind of versatile IDE. Basically, here you can run all of these languages in a single environment. Okay. So whenever you are working, we are going. I'm just explaining things, explaining the differences. Okay. So basically, when we are working in some kind of office, we are working on multiple programming languages at the same time. Like we are using JavaScript and all kind of different languages. Then the environment in an office is basically more VS Code oriented, so they have to use VS Code. But if you are working in education, like if you are working on your university project or university courses, Google Colab is the best choice.
Okay.
Okay, so let's talk about a few things. Now, Google Colab is simple. You just need to open Google Colab and you just need to open the file and create the file and you're good to go. For Jupyter Notebook, you have to install Jupyter Anaconda Navigator that you already installed. So I'm not going to show you that how you can do that. but that's quite simple. Okay. Now, in data science, in this throughout this course, we are going to be sometime we are going to talk about statistics and mathematics, sometime we're going to talk about computer science and programming, and sometime we're going to talk about domain expertise. Now, domain expertise basically means even though we are going to work on some kind of data set, we have to understand what's behind the data set, right? If we don't know what the data set is actually about, this is not going to work out. So basically, programming or mathematics is not the start of any kind of problem. Whenever we are starting to work on something, we must start with what is the domain, like what kind of problem we are trying to solve, right? For example, now there are some real kind of application of data science. Now Netflix, right? We all use Netflix, and whenever we go to Netflix, we see like they already recommend us the movie based on what we have previously watched, right? Now this is not their problem that they are going to use Python or they are going to use what kind of programming language they're going to use. The main thing is they have a problem in hand that they need to understand and they need to provide a solution based on that, right? That's what we call domain expertise. So whatever the problem we're going to talk about, we're going to talk about what basically we are trying to do here. Okay. So if you are trying to solve anything with programming and mathematics, so it you must have 100% clear in your mind what you're trying to do. Okay. If you don't understand your data set, if you don't understand what you're trying to do, so then there will be problems that leads to the mathematics and the programming as well. So whenever we talk about any kind of data science project, there will be three things. First, we need to identify domain, what we are trying to do. Then we need to understand and we need to use mathematics and programming to solve the problem, right? Now, there's a crisp DM is basically a process that basically simplify things. Like we need to understand we must have business understanding, like defining the object, what we need to do, right? Once we have that, we need to collect and explore the data set. Now, since we are data scientists and we are always going to work on the data sets. So we either get a data set from some open source, like we get it from online internet, or we will collect data set or something like that. Okay. So whenever we are going to tackle a problem, we are always going to tackle a problem with data sets. Okay.
Okay.
If you have any question, just shoot. Okay.
No, I don't have a question.
Okay. So now we have the data understanding and now we have a problem. We are good. So if we are starting a project, we are good. We understand what we need to do. Based on that, we collected the data set. We either downloaded it from on internet or we just collected it or we just spread the Google Forms in online groups and we collected our data set. Okay. And after doing that, what we need to do is we need to transform our data set. We use different kind of processing that we will discuss in detail in the next few sessions. Okay. So what we will do is we will clean our data set, we will identify the problems, we will remove the problems, we will make sure our data set is extremely good quality before implementing to machine learning or modeling. Now, after doing that, we have modeling. In modeling process, what we do is we implement machine learning models. We generate predictions, or we generate statistical inference. Like we explore relationships and we explore that what insights we can get from our data set. Based on that, we define, we produce a solution for our problem that we are basically dealing with. Okay. And there are some real world applications. Okay. And in the same manner, we have fraud detection. If we apply for a loan, sometime it get approved, sometime it get rejected based on our application. So basically behind all that, we have a model that is predicting that either we are going to repay the loan or we will ditch it. Okay.
Okay.
In the same manner, we can now what the doctors do, they take a history from you that you earlier had this disease and you are healthy, you are that height, and all kind of things. and based on that they prescribe that you might have this particular disease, right? Similarly, we can mimic that process in machine learning, where we take the data set and based on that data we generate predictions. So in the next couple of sessions we will do all these kinds of projects, and we will understand that how we can implement machine learning in the real world scenario. Did you have any question?
No.
Cool. So if you have any question, you can just ask, okay? Now,
Mm,
why Python? Python is mostly used for data science, and the main reason is it has rich libraries. We have a lot of libraries that we can use for data science. We have pre-added machine learning models. We have everything basically built in Python programming. We just import a package and we got a solution for that. Okay. It's easy to learn, simple. Now, if we compare Python programming with the previous programming languages like C or something like that, they are quite complex and their syntax or basically coding style is quite vast instead of short syntax. In Python, we just write single line of code and we get results. But the previous programming languages, we don't have this luxury. So it's easy to learn. Rich ecosystem. We have a lot of libraries. We can just import the library, and based on that, we can use the functions for different things. If we are using some numerical computation, we just import the NumPy, and we have all kind of functions. For data manipulation, we use pandas. Similarly, for data visualization, we use Seaborn and also Matplotlib. And for machine learning models, we have TensorFlow, scikit-learn, and all that. Okay. And the good thing is we have Jupyter Notebook. So basically we can present our results in the form of HTML or PDF if we need to. And the next is the ecosystem, where we can set our environment, like we can go with Anaconda distributions. Anaconda basically means Jupyter Notebook. Jupyter Notebook is basically a package in Anaconda Navigator. Okay. And we can use VS Code or Google Colab. So for this, we are going to use Google Colab. Now, we will use different data sets, and based on that, we will generate results, and we will implement machine learning models, and we will understand that how we can use them in our projects. Cool. So basically, you already worked on some data science projects, right?
yes.
Cool. Okay, so in Jupyter Notebook or in Google Colab, we have a function time iteration. Okay, and it basically tells us that whatever we run, it will just tell us the time, that how much time it takes. Okay, and the new sign is basically for micro, basically means 0.000 and then 1. Okay, so the good thing is in Jupyter Notebook, now few things that we need to understand. If you're writing code and you can either go with your keyboard or you can go with the mouse and keyboard. Like if I write the code and then I will need to grab my mouse and then I will need to run it, right? But this is a lazy way, and a better way is to just use shift enter or control enter. Okay. If you use shift enter from your keyboard, it will run that particular chunk and move the cursor to the next chunk. And if you are trying to add something else and you don't want to go to the next chunk, you can just use control enter. It will run the code and it will stay in the same chunk. Got it? Basically, chunk mean the code, where the block for the code. Okay. Hello.
Yes.
Okay. Cool. And these are basically some shortcuts that helps you when you're for your better experience when you're writing code. Now, if you are in chunk and you run this, after that, if you want to insert a new cell below, you can just type B from your keyboard and it will create a new cell below it, the like this. And if you run something and you want to add a code cell above it, you can just type A from your keyboard. So basically, there are some shortcuts that are better if you are going to work in Jupyter Notebook. No, time IT is basically a command to explore if you're coding something and you want to see that how much time it is going to take to run, so you can just use it. Okay. And this is not something related to Python. It is a function that we get with Google Colab or Jupyter Notebook to note the time for running the code. Okay. In the same manner, if we have different different type of codes, we can just use these to calculate the time. So basically, this is a small function that we get with Colab. So I thought I should tell you about that. Now, whenever we are working in Python or in Google Colab, we have a working directory, like a folder that our laptop is using to load the data sets and to create the files and everything, right? We call it working directory. And if we want to see what is our working directory or where our Python is loading files and everything, we can use pwd with a percentage sign. Okay. Now, since we are in Google Colab, that's why we are getting slash content, basically the content of Google Colab. Okay. But when you are in using Jupyter Notebook, you will get a path to your a folder that where everything is located or where that Python is using for the data files and everything. Got it? Now, if I run this particular line of code in Jupyter Notebook, and it is showing me that right now our current working directory is C user Sajid. So basically, it's a folder in my laptop that it is using for Python. So basically, it is using that to load the data files and to save that particular file. If I save this file, it will go to this particular folder. Okay, like if you are trying to work on some Python project and you created a file and then you are unable to find it in your laptop, that where does it go? So basically, this is the command that will help you in such a case. And you can also use the ls command. This will basically show you that what type of files you already have in your working directory. Okay, so it will list all the files, but since we are in Google Colab, there are no files right now. If we go back, we thought we talk about that. For data science, we work on mostly we work on these packages. We work on NumPy, we work on Pandas, we work on Matplotlib, Seaborn, and scikit-learn. Okay. And these packages are sometime, if we are using Jupyter Notebook, they might be already added. If they are not added in your Jupyter Notebook, or if you're trying to run something and it gives you error. So basically, in the general sense, everything that we use in Python comes from some particular package. Okay. And we must have that package in our environment. Like if we are going to use NumPy or Pandas, we are going to import them in Python first. And after that, it will work. Like if I run it, it will show you that library is imported successfully. So let me explain what we have here. Now, NumPy, Pandas, Matplotlib, Seaborn, they are packages that they are not a part of Python, but we can install them in Python and we can use them in Python as well. Okay. And here what we are doing is we are importing NumPy, we are importing Pandas, we are importing Matplotlib and Seaborn. Okay. And when we import something, we have to provide a reference to it. Like if I am going to use Matplotlib, I am going to write matplotlib and then the function that I'm going to use from that particular package, right? So a good practice is to just give it a smaller name. Like for NumPy, I just give it a name as NP. For pandas, we give it a name as PD. So basically what we are going to achieve from here is whenever we need to use this particular function, we can just write NP and then go on with the function. Like in that particular case, we use this particular function from matplotlib, right? And we just write plt dot this function, right? If we don't define it as a plt, we have to write all that here. We need to write matplotlib dot py plot dot, all that. So basically, this is the main reason that we use as in import. Do you understand?
Yes.
Do you have any question?
No.
Okay. Now, for this particular session, we are going to work on some simple data set, and we will explore it differently, different perspective from the data sets. Okay, now the data set that we are going to work on right now is this one. The data set is available on GitHub. It's a titanic.csv file. It contains passenger IDs, the ID for a passenger. If he survived, it has a value 0, 1, and if he didn't survive, it has a value 0. Okay, P class. So basically, it was the first class passenger or not, name of the passenger, gender, age, and different kind of details. So we have a data set, and we want to explore the data set based on our programming skills. Okay. Now, pandas gives us multiple functions, and one of them is to load the data set. So whenever we are trying to load the data set, either it is from our laptop or from internet, we can just use function read CSV. Now, why we are using CSV? Because the data set that we are going to use is also in the CSV format. Okay, we define the link to the data, and we just give it a name URL. After that, we can just give the URL to our function that load the data set, and we can give it a name. We give it a name df. Okay. Now, once we run these lines of code, what it will do is it will save this URL and use the function from pandas package read CSV, load the data set into our environment. No, the name of the data set that we give it is a df. And if the code works, then it will print these commands as well. If it didn't work, we will see an error. So we have dataset loaded successfully from the GitHub. We use shape. Now shape is a function that basically show us the number of rows and number of columns of the dataset. If we want to present it something like that, shape is equal to 891 rows and 12 columns. We can use something like this. Now in print, let me show you something. We have a function print, like instead of just doing it here, let me now print basically prints whatever we write in it, right? Like if I want to use some, also want to use some kind of coding in it as well, like we have a data frame df.shape, right? And I want to use it in the print, I cannot use it directly. Like if I do this, it will not work. Okay, and it will only work when we will provide an f string here. So basically the main purpose of f string is that it should understand that whatever is in curly brackets is basically a code, and it should execute the code. Okay, so whenever we're writing f here, it basically means that this is particular string is not only a string but code as well. So basically when I'm talking about strings basically means simple words, and the code is basically that execute and show results. Like if we run this, we get shape is equal to the actual shape and the actual number of columns in the data set. Now we loaded the data set. After that, what we can do is we can see that how many rows are in there, how many columns are in there. We can list all the column names. Like we get a list of column names. We have passenger ID, survived, peak, last name, and all that. Okay. The head function is basically to generate the first 5 rows of the data set. And here are some details about the data set that we have. Actually, we have a passenger ID that is unique for each passenger. We have a survive status, 0 for no, 1 for yes. Basically means if that particular person is survived the Titanic fall, it is going to be 0. it is going to be 1, otherwise it's going to be 0. Okay, so this person basically died during the Titanic fall. That's why we have survived is equal to 0. And now here we have all the details about the ticket number, passenger fare, cabin number, all that. Okay, now what we are basically trying to do here is we are trying to understand that what basically can help to increase the survival analysis. Like the insights that people survived, we need to generate the insights and we need to give them. So basically, based on that, they can identify the survival rates for different scenarios. Now, whenever you load the data set in Python or in any environment like Google Colab or Notebook, first you need to ensure that your data set is loaded. Once the data set is loaded, you can see the head command will show you something like that, and shape command will also show you something like that. But after that, we need to identify that how many missing values are in there. So missing values basically whenever we have a data set and there are no entries for some particular cell, we say it's a missing value. Okay. And to ensure that, we have a command data in df.info. Okay. Now here we are using on df.info. So basically what it will do is it will tell us that how many rows are in there, 891, how many columns are in there, list all the columns, how many non-null values. So basically non-null values means actual values in the data file. Like we have 891 entries total. For passenger IDs, we have all non-null, means we have all actual values. But for age, we have 714. Okay, so basically there are some kind of missing values that we need to treat. In the same manner, for cabin, we have 204. And each column have a different data type. For example, passenger ID is integer. Integers are basically numbers from like 0,
Yes,
1
yes,
to.
I know. It's okay.
Okay, and floats are like decimals and all that. No, these are some basic things from the data sets, and now some statistics here. We use df.describe. Df.describe is another function that helps us to understand different numerical columns in our data set. Like what is the minimum value of particular column? What is the maximum value? For example, if we are talking about the age, what is the minimum value of age for some particular things? Here we are seeing 0.42. Okay, so basically the age is, and the maximum is 80. Now, if we talk about 0.42, we are going to see some very little kid, newborn kid with few months. In the same manner, we can see the mean average age of a person on the Titanic is 29. In the same manner, we can see different statistics here. Now, 25% basically means 25% means 25% of the people on the boat have aged around 20. Okay, 50% of the people have age around 28, 28 or less than that. 75% of the people are either 38 or less than 38. Okay, so basically we can understand different kind of statistics from there. Now let's talk about the programming that we can implement to see different relationship between different variables, right? Now, where we are using print, this command is basically just to beautify that particular thing. Like if we want to remove these lines, we can just remove them and run it, and it will still work. Okay. Now, first we are talking about survival rate. Like if we want to identify the survival rate, we must need to know what columns from our data set can helps us to identify that, right?
Okay.
Okay. Now we have a column survived that have values like 0 and 1, right? What we can do is we can say if survived is the name of the column, is present in that particular thing, particular in column names, we need survival rate. So basically what we will do is we will take a mean for survived column. Okay, this particular thing, df.survived.mean. Now, for programming, let me explain something. I'm just zooming it a bit. Whenever we are using these small brackets, it means we are using a function. Like here we are using mean small brackets, basically mean we are using mean function. Okay. And when we are using large brackets, it basically means we are using something from data set. Like in these brackets, we are basically using survived column from data frame df. In the same manner, here we are using survived column and we are using dot sum function. Okay.
Yes.
Now we get the percentage of overall survival rate. What we did is we just take the survived column and we just put the mean function over it. Okay. And now if we want to see the passenger who survived, like how many total passengers survived, instead of we can just take the sum function and it will show us that it will just count them all and it will just give us a number instead of percentage, right? And we are getting like 342%, so 342 people survived during the fall. Okay. And in the same manner, if we want to see the people that don't survive, now we know that this particular thing, this particular code is calculating the survived one, right? What we can do is we can take the total length of the call data set and remove this thing to get the people that didn't survive, right? It's simple as that. Like we have the number 342 that survived and we take the whole data set, like we have 891 entries, we just minus it from this one and get the actual people who didn't survive. Okay. Now let's talk about the passenger class distribution. Like there are three different classes, 1, 2, 3. Now whenever we are talking about numerical variables like age and something like that, summary tells us a lot of things, but summary don't tell us anything about the variables that have categories, like categorical one. Like the passenger class is basically a categorical one, and if we see here passenger class, it doesn't tell us anything. Like minimum is 1, maximum is 3, average has nothing to do with the categories. Like 2.3 doesn't make any sense if we are talking about categories. Like we know. Okay. Now instead of taking mean or average or something like that, we count them. And to count them, we use function values.count. Okay. We select a the p class one column from our data set and we use values count to count the total values in each class. Like there are three classes. We have first one and it has 216 passengers, second one 184, third one 491. Okay. Now we use sort index basically because we want to see 1, 2, 3 in proper order. If we don't do that, our order might get messed up. Like we first seeing 3 and then 1 and then 2. Now we are using a loop there. If p class is in data frame, if this particular column is in data frame, then we need to see this. Like if you are 100% sure that this is already available in the data set, you don't need to do that. You just remove it, and just simple as that. Okay. And basically we want to see what we saved in the p class count. That's why we need to print it as well. And it will still works. Okay. In the same manner, if now these things that we are exploring right now is based on single column, and in the next few chunks we will go to the double column ones and we will create some visualizations based on that.